Hello, today we're going to discuss how to solve systems of equations by elimination. Okay, so same deal as before when we learned about how to solve systems of equations with substitutions. Systems of equations is two or more equations with shared variables. For example, two equations are shown there where they're intersecting on a graph, and you can find the point that is intersecting, which there you can see is 1, 5. Okay, so how to figure out where intersections occur. So, two equations are the same equations as that previous slide. Now, what to do with elimination is you basically have to change one of the equations to where you are able to cancel out one of the variables that we are working with. So if I multiply that whole first equation by 3, I get 3x plus 3y equals 18. Now with elimination, what you do is you literally add those two equations together. So now that positive 3x and negative 3x, they cancel each other out to make 0x or 0. Then we do 3y plus y, which is 4y, and then our now 18 plus 2 equals 20. Then what happens is we solve for the rest of it. So 4y equals 20, and y equals 5. We divide 20 by 4. Then what we do is we take that y equals 5, so now we know what y is, plug that into one of our equations. So I just picked the first one because it's easier. So x plus 5 equals 6, subtract 5, and x equals 1. So our x is 1, y is 5, and yep, that happens to be a point where those equations intersect with each other. Okay, word problem. Same word problem as the substitution one. So a fundraiser dinner charges adults $22 per plate, while children are charged $15 per plate. The total cost of plates for a party of 11 people is $228. Write and solve a system of equations to find how many children and how many adults were in the group. Assume that each person gets only one plate. Alright, so every time we gotta start with what we know when we get a word problem. So what we know is adults, $22 a plate, children, $15 a plate, total cost, $228, and total people, 11. So using this information, we're going to make two equations where we have A equaling adults and C equaling children. So if one of our equations is finding the number of people, that would be A plus C, so adults plus children equals 11. And then if we're trying to figure out the total price, that equation would be 22A, so $22 per adult plate, plus $15 per child plate C equals 228. And then what we're going to do is we're going to make it so one of those variables can cancel out the other. So I just happen to pick A because it's the first variable in the first equation. So if you multiply that whole top equation by negative 22, we can then cancel out the 22A's when we're adding them up. So when you multiply that whole top equation by negative 22, it becomes negative 22A minus 22C minus 200, or equals negative 242. Then you add both those equations together. You end up getting 0A because the 22's cancel out, because one's positive, one's negative. Then negative 22C plus 15C makes a negative 7C. And then negative 242 plus a positive 228 equals negative 14. We divide negative 14 by negative 7, and we get that C equals 2. All right, now we know that C equals 2, so that there were two children there. So again, writing out what we know, we know 2 children yet again. We're going to plug that into one of our equations. Don't need to change anything at all. Just plug it in. A plus 2 equals 11. Subtract the 2 from the 11 and you get 8 equals 9 for 9 adults and 2 children. Thank you for watching. Please share and subscribe. And remember to spread kindness.